Okay, so now look at the example 2. So we have to compute the line integral for the integrand is y with respect to arc length along or over the curve C. So the information of the curve is given by in parametric form, where you have the x equal to t squared and y is equal to t, and the limit of t also given from 0 to 2. Okay, as we know that if you are given a parametric equation, so we can have the vector function, right? Where the parametric equation that we have is actually the equation of the R in component form. So you can just substitute for x component, we have t squared, and for y component, we have t. And from there, we can obtain the speed, which means that you have to first differentiate. So you got 2t1, and then you find the magnitude of the R prime. So you have the square root of 4t squared plus 1. So now you can see that the magnitude of R prime is not a constant, but it is an expression in terms of t. So now we want to have the s in terms of dt. So by using the magnitude of R prime dt, and we just substitute, the magnitude of R prime is 1 square root of 1 plus 4t squared dt. So now we substitute the ds that we obtain here. So now we have the y. So y in terms of t is y equal to t, right? So we just replace y equal to t, and the ds is the square root of 1 plus 4t squared dt. Okay, so now from the line integral, so it reduced to a common line integral, definite integral, right? Simple integration. Okay, so now you ask yourself, what is the most appropriate integration technique here? If there is no t, it's just a square root, then it is a bit complicated to be done, because you have to apply the trigonometric substitution. But luckily you have t outside, which means that you can just use direct substitution. So in this case, we let u equal to 1 plus 4t squared, and then when you use the u, meaning that your intention is to convert everything here in terms of t into in terms of only u. So now we want to convert the dt in terms of du. So you have to differentiate u with respect to t. So you have 8t, and then what is dt? So dt is du over 8t. Okay, and then we substitute. So t, and this one is square root u, and dt is du over 8t. So now you can see that the t here can be cancelled out. So you only have 1 over 8 u to the power of half du. So now your integrand becomes more simpler form. Then we can directly integrate this. So from u 1 over 2, then it's become 3 over 2 multiplied by 2 over 3. And when we simplify, so we have this one. Then you cannot directly substitute the limit here, because this one belongs to t. So you have to replace back what is your u in terms of t. And after that, you substitute t from 0 to 2. So then when you do some step here, just substitute all the value of value of t, and finally we will get this answer. So for your information, you can leave your answer in this form, but please don't leave your answer in this form. So if you give me this, you will lose 1 mark, because your answer is incomplete. But if this one, it is okay. But if the instructions say that you have to leave your answer in 4 decimal places, meaning that you have to evaluate and leave your answer in 4 decimal places. So you have to read carefully the instruction. Okay, so that is the example 2. Okay, so here the thing that you have to take note. So if you realize, when we have the line integral here, so after some step, it became an ordinary definite integral. Okay, by using the appropriate parametric component, where we just use the RT. Okay, So next, in example 3, we still discussing on the line integral for the scalar field. This is scalar function along the C, but now your C is not in terms of parametric equation or vector function. So you only have the 2 points, 1, 2, and 4, 7. Okay, so now your C is the line segment joining the point 1, 2 to 4, 7. Segment here means a straight line joining the point 1, 2 to 4, 7. So that is your curve. So now in order for you to solve the line integral here, you have to have the vector RT, or at least the parametric equation. Okay, so I think in the notes in the beginning, our first meeting, I share with you a few slides on the revision of the vector function. Okay, so maybe you can just look at it again. So there is the information tell you how can you obtain the vector function if you have a line segment. Okay, so the formula that you have to have in order for you to obtain the vector function, which means that you want to have the vector function for the given point. So you have to apply this formula, R0 plus TV. So R0 is a position vector, and V is vector parallel to this line. So you must have this. You must have these two information, the position vector and the vector parallel to this line. Okay, and T is the parameter T. Okay, because you want to have the parametric equation, so your equation must be contains the T, the parameter in terms of T. Okay, now what is R0? How can you have the R0 from the curve that you have? So R0 is the position vector. So how can we get the position vector? So since you have 2 points here, whether at the point 1, 2 or at the point 4, 7, so that is a point, right? We call that as a point 1, 2, 4, 7. And from the point, we can have the R0, which is a vector. So because you have 2 points, so you can choose either one. Your final answer will be the same. So let's say I'm using a simpler form of the point. So from the point, I put into a vector form. So I use a square, the sharp band bracket here. Okay, so that is for component X, and for component Y is 2. So that is the R0 position vector at the point 1, 2. We have the vector 1, 2. Okay, and what is V? V is a vector parallel to the line. So we only have this. The information that we have so far is only these 2 points. Can we have the displacement vector? Do you know what is the displacement vector? The vector from the point 1, 2 to 4, 7. How can we get the displacement vector? So you just for the component X, you just find the subtraction between 4 and 1. So let's say I'm choosing this one just like a terminal point. So for X component, 4 minus 1, and for Y component, you have 7 minus 2. So your displacement vector is 3, 5. So now we have the R0 and V. So we just put that 1, 2 plus the V is 3, 5. This is very important, yeah. So you will have the problem about finding the vector function of the straight line again and again along this course. So maybe in final exam, maybe in test 2, there is a need for you to obtain the vector function of the straight line. Then you have to know this. Okay. So when we simplify into a component form X and component form of Y, so we have 1 plus 3t, and for component Y we have 2 plus 5t. So that is your RT. Okay, so we already obtained that vector of this line or this curve. So now we want to so this is the RT that we are looking for. So now we want to find out the the speed, which means that you have to differentiate, and this will give you 3 and 5, and then find its magnitude. So 9 plus 25. So you have the square root 34. So your ds is r prime, the magnitude of r prime t dt, where you will get square root of 34 dt. Okay, so now we can convert this line integral in terms of t. So y, where is your y? So this is your y, and this is your x. So you have 2 plus 5t e to the power of 1 plus 3 t dt. Okay, so you need to have the limit. The limit is not given. Then how can we determine the t? Okay, so how can we relate the information that we have on the curve and the RT that you have? So meaning that this curve can be represented in terms of vector form given by x equal to 1 plus 3t, y equal to 2 plus 5t. So now you have the point x equal to 1, y equal to 2. So for that is maybe we can consider that to be the initial point. So you have to find the t for this point, and you have to find the t at this point. Okay, so now look at your r. Look at your vector function here. Okay, tell me what is the value of t so that you can have 1 and y equal to 2. Okay, again, I repeat, what is the value of x? What is the value of t so that your x equal to 1 and your y is equal to 2? So your t should be satisfied both x and y equation. So it should be when t equal to 0. So to have x equal to 1, and y equal to 2, so the t should be equal to 0. And now tell me what is the value of t so that the x is 4 and the y is 7. 4, 7. 4, 7. So t is equal to 1. Then from the point we can determine the t. So the t is from 0 to 1. So now you can see that from the line integral, so it transforms into a regular definite integral in terms of t. Now you have the polynomial and you have the combination. In your integrand, you have the combination of the polynomial and the exponential function. So how can you integrate this? It looks like you can use the tabular method, right? Tabular method is what is the tabular method? Is the part of the tabular method is the generalized form of the by parts. Okay, by parts. So you have to something 2 plus 5t, the polynomial, and you have maybe I have to simplify that first. So 2 plus 5t multiplied by e1 plus 3t. So 2 plus 5t, you have e multiplied by e3t. So you have 1, e1 is constant. So maybe I should rewrite the integral here. So I have the e1, I can we have 2 plus 5t and e multiplied by e3t dt. So now E1 is constant and I can take it out. Now we only have 2 plus 5t multiplied by E, 3t dt, t0 to 1. Okay, so now we want to implement the by parts. By parts, you have the polynomial part to be differentiate, and you have the exponential part to be integrate E 3t. Okay, so this one to be integrate and this one to be differentiate. So I hope that you know how to provide the tabular method. So differentiate, so you have 5 and you got 0, and the second column you follow through. So integrate E 3t, so you will get E 3t over 3, and then integrate again E 3t over 9, and you have to make a pair between of them. This one. So start with positive, negative, positive. Okay, so now you will get the answer directly. So you have 2 plus 5t E 3t over 3 minus 5 over 9 E 3t. So that is your answer using the tabular method. So E, and just copy the answer. 2 plus 5t E 3t over 3 minus 5 over 9 E 3t, and t0 to 1. Okay, and then we evaluate that. I do a mistake here. I did a mistake here where I forgotten to put the square root 34, right? So then I have to put the square root 34 and square root 34 and then square root 34 here. Okay, when you substitute 0 to 1, and this one 7 over 3 multiplied by E3 minus 5 over 9 E3. That is when t equal to 1 minus when t is equal to 0. So this one 0. So 2E0 is 1. So I just put 2 over 3 E0 minus 5 over 9 E0. And this one, we can simplify this. We will get 16 over 9 minus. So this one also can be simplified because E0 is 1. So when you simplify this, we get negative 1 over 9. And then also we can simplify this form. And finally, we will get this one. Okay.